Hi class, today we're going to be doing our data analysis lesson 2. We're going to be talking about quantitative data today. We talked about categorical data last time. So quantitative variables contain measured numerical values. So numerical is kind of the key piece there, but it's numbers that were measured, and they have measurement units. So the data that we record an amount or a degree of something that's quantitative in nature. Quantitative data condition is that the data have to be values of a quantitative variable whose units are known. So we have to know what those numbers represent. Here are some examples. So quantitative data displays. The first one is a histogram. It's a frequency histogram. We also have what's called a relative frequency histogram, which we'll look at. The second one we call a stem and leaf plot, or just a stem plot for short. The third one, we have a dot plot, and the fourth one, we have a box plot. We're going to look at histograms, stem plots, and dot plots today, and we're going to look at box plots in another lesson. So starting with a histogram, unlike a bar chart, and I know it looks a lot like a bar chart that we saw in the last lesson with categorical variables, but unlike a bar chart, the bars of a histogram touch each other. And if you notice, the horizontal axis is a number line. So that's kind of another key feature. So you could write horizontal axis is a number line, which is why it doesn't make sense to space out the bars like we do in a bar chart. They have to touch each other because it's a number line. This feature is necessary in order to reveal gaps in the quantitative data set. So if there are two bars that aren't touching, it means there's a gap in the data set for those values. The bars generally straddle values that are discrete. So you can see down here, discrete. Number of children, they're discrete because not every possible number is a possibility. You can't have 1.2 children. And notice that the numerical values are right in the middle of each one of these bars. So that's what I mean by straddle. And then continuous values are the boundaries for each interval. So here, continuous height in centimeters of a tree is a continuous variable, and you can see that the numbers aren't in the middle of the bars, they're on the boundaries of the bars. And the boundaries need to be really specific. So the minimum value of each bar corresponds to a greater than or equal to value. So each bar includes the minimum value, but excludes the max. So you can kind of see how I wrote this here. 100 is included in this first bar, but 150 is not. 150 would then be included in the second bar. And it's really important that you don't get those mixed up, or your histogram will not look correct. Example 1, students in a biology class recorded the heights in centimeters of plants for an experiment. Their data is summarized in the table below. And then this little thing, this is called the sum. And that's just for us to check to make sure we wrote down all the numbers right. If you're using a graphing calculator, there's a one var stats in your graphing calculator that will give you the sum after you put a list of values in there. And you can always check to see if your list is correct by doing that. Now, I usually teach this lesson using a graphing calculator, but because we are distance learning right now, and some of you don't have graphing calculators and they cost money, I am actually going to show you how to use Desmos and other free online tools to create histograms and all of our other plots that we're going to be doing. So we're going to actually use Desmos for this first one. And on our course calendar, I linked this website, which explains to you how to input the things for box plots and dot plots and histograms and kind of how to do that. And I'll show you a little bit in the example I'm doing today. So that page right there is linked to your course calendar. All right, so sketching a histogram, before we need a calculator, we can at least set this up, label our axes, scale our axes, that sort of thing. So our horizontal axis is going to be our plant heights, so heights of plants, and we want to make sure that we include the units because centimeters or feet are very, very different. So we want to make sure what these numbers represent. And then here we're just going to do a frequency histogram for this example. And we'll figure out what to scale that in a minute once we kind of see a good picture on Desmos. We can make these by hand, but when we have tools available to us, why not make our lives a little easier? All right, so let's go into Desmos. And so if you look at the first two equation boxes here on the left, those are my two for the histogram. We're going to do a box or a dot plot later today. So the first thing I want to do is I just put L equals square brackets, and I listed all 20 of those numbers with commas in between. So I just went through these numbers in the table, listed them with commas in between, and hit enter. And then I typed in histogram of L. And I can set my bin width, which means the width of each bar or bin, as whatever I want. And I decided that 10 would be a nice width. And you can kind of play around with the bin width to see how, what looks right. Now, the bin alignment center versus left, this is where that discrete versus continuous variable comes in. Plant heights, which is what we have here, are continuous variables. So I'm going to do the left alignment so that my numbers are the boundaries between my bins, not center. And here I've got count as opposed to relative frequency. So I'm going to just do count because I'm just doing frequency. And then this little plus sign in the magnifying glass here allows it to just kind of zoom it in a way that lets you make sure to see the whole thing. All right, and let's see. So another thing that's kind of nice on Desmos is if you go up here to the little wrench settings icon, you can title your x-axis and your y-axis. So whoops, I don't need that. I already did it. So you can see my titles, heights of plants in centimeters and frequency, so that even on my graph here, if you were going to take a screenshot of this and put it in a document or something, you can title it inside Desmos. So we can use this to help us draw our graph. We've got, so it looks like increments of 5 here, and it's hard to tell exactly what this height is over here. So maybe I want to make this a little bit easier to read. I don't need my y-axis to go up quite as much. So I'm going to make it go up to just, let's call it 20. I don't need it to go down to negative 35. We'll just say negative 5. Oops. Negative 5. Or 0. Okay, and then the step, I can change it so it steps at 1 so that I can see exactly how many I have in each one of my bins. And then I can just kind of readjust this graph so I can see the whole thing. So now I can really see what my values are. So from 30 to 40 on my x-axis, it goes up to 3. From 40 to 50, it goes up to 7. 50 to 60, it goes up to 6. So that's my frequency there. 60 to 70 goes up to 3. And then 70 to 80 is only 1. So that's how many plants are in those height bins, I guess, intervals. So drawing this in, I'm going to start at 30. And we can technically, I can do these 2 little slashes here. Instead of having to start at 0 and counting all the way over to from 0 to 30, those 2 little slashes just represent a break in my horizontal axis so that I can start wherever I want. And I'm going to go 30, 40, 50, 60, 70, 80. Because that's what I have there. And I know from my graph that the highest I went was 7. So 1, 2, 3, 4, 5, 6, 7. There we go. 1. Okay, so then I said that the first one went up to 3. So I'm going to draw that up to 3. The second interval from 40 to 50 went all the way up to 7. And again, try to make them the same width. From 50 to 60, we went up to 6. From 60 to 70, we were back down at 3. And oops, I missed. And 70 to 80, I was down at 1. All right, and there is our histogram. We have it all labeled, scaled. I know that the numbers represent heights of plants in centimeters. I know that I'm using frequency, and I used my tool to make my life a little easier. All right, next we're going to look at a relative frequency histogram. It's going to look exactly the same. If I did a relative frequency histogram with this data, it would look exactly the same shape, but my vertical axis would reflect the percentage or proportion of my observations within each interval instead of the count. So we saw kind of a frequency versus relative frequency in our bar charts in the last lesson. It's kind of the same. It's pretty much exactly the same. Here's an example of relative frequency of a different data set. So you can see that the relative frequency values go from 0 to 0.3. So that's like 0 to 30%. And that's really the only difference. So only difference. Okay. Moving on, let's look at a stem and leaf graph. A stem and leaf display is like a histogram, but a stem and leaf shows the individual data values. Precision must be exercised to avoid creating a misleading stem and leaf display by carefully aligning each leaf value in numerical order. In addition, a key must be included in context. And we need a title. We always need a title. And you can put the title above your stem and leaf plot, but I was a little limited on room again, so I'm putting it to the side. Now, Desmos, I couldn't figure out a stem and leaf display on Desmos, so I Googled a different one, and I linked this website to our calendar as well. So you're welcome to use this. I found it really easy to use. I just typed in the data set again with commas in between, and this is the same data set I had before, so I actually just copied it from Desmos and pasted it in here. It was nice and easy. And then you hit calculate, and it creates your stem and leaf plot. It also gives you a bunch of nice statistics below that if we ever needed any of it. All right, so our stem and leaf, it looks like this. Our stems are only one digit. Your stems are only, or no, I'm sorry. Your stems can be multiple digits, but your leaves can only be one digit. So let's just make ourselves a little note. Leaves can only, oh, my pen is lagging, be one digit. Stems can be as many digits as you need them to be. Now, all of my numbers are only 2 digits long, so I only need 1 digit in my stem. And I'm going to start with 3 for 30s, 40s, 50s, 60s, 70s. And I don't think we had any 80s. One of the ways we can see that actually here, it shows you basic statistics. Min was at 32 and max was at 75. So I know we don't have to go any farther than 7. And then the leaves are going to be the numbers. So if I look back at my original data set here, my lowest value is 32. And then I also had a 36 and a 38. So you can see 32, 36, 38. Those are the 330 values in the 30s that we showed in our histogram. We had 3 things between 30 and 40. It was those 3 things. So now if I take 32, 36, and 38, I can write 32, 36, and 38. And that represents the 30 to 40 or the 30s values for 30 centimeters. In your stem and leaf plot, you can see that 2, 6, 8 there. And I want you to notice how nicely lined up all those leaf values are. And that's really important. We can't have some of our leaf rows more spread out and some of them more clumped together. They all have to be spaced out the same. So, all right, so my 4s, we can just kind of copy these in here. I have a 1, a 3, a 4, an 8. Oh, and I'm going to run into my key here. So I'm going to erase that and I'll just have to add a key a little farther over. I have another 8 and another 8. I have 3 8s and then a 9. And then I can put my key back over here. So, and we'll talk about the key in a second. For my 50s, I have 52, 53, 54, 55, 56, and 59. Notice how I'm lining up my leaf numbers really carefully. 60, 62, and 67, and 75. So there's my stem and leaf graph. I have my title. Now the key can be written in a couple different ways. My favorite way is to write it like this. You do a 3 or any number from the stems, and then a vertical line to represent the boundary between stem and leaf, and then just any number from the leaves that you have, and then you say that equals, and then you tell me what that is in context. This means 38 centimeters. So that can be, that's one way to show a key for a stem and leaf plot. We also have a secondary type of stem and leaf plot. It's called a split stem and leaf. When you have only a few stems, you can split them to create a better shape. Our first stem is going to have leaves from 0 to 4, and our second stem is going to have leaves from 5 to 9. So if we look at this, it would look like 3, 3, and 4, 4, and 5, 5, and 6, 6, and 7, 7. I got a little squished there, but we're splitting the stems so that we have more of them. And then my first stem is going to go 0 to 4. So in the 30s, the only number I had there was a 2. That's a 2. The second one, I had a 6 and an 8. In the 40s, I have a 1, a 3, and a 4. 1, 3, 4. And 3 8s and a 9. So 8, 8, 8, 9. In the 50s, I've got a 2, 3, 4, 2, 3, 4, and 5, 6, 9, 6, and 9. Sorry, my pen is lagging still. 60, 62, and 67. And then I don't have any's in the 0 to 4 range for my 70s, but I do have a 5. So I'm going to show that gap in between there. And this is the same data. It just gives us a little bit of a different way to look at the shape. If we look at it here, we only have 1, 2, 3, 4, 5 intervals. Here I now have 10 intervals. So it just gives me a little bit more of a shape. Again, my key is going to be the same kind of thing. We're going to write one of our stems. So we've got 3, and then our vertical line 2, and then we say what that represents, 32 centimeters in context. All right, our last type of graph today is going to be a dot plot. The dot plot is like a stem and leaf, but uses dots instead of digits for all the leaf values. A dot plot can extend either vertically or horizontally. So here I have the data of the number of unicorns captured and tagged in 20 enchanted forests. And again, Desmos can create a dot plot for us pretty nicely. Here I can go, I'm going to get rid of my histogram pieces there. And I listed all of my numbers. Oh, I can also get rid of my labels. And I should label this with new labels, but it's harder for me right now while I'm making a video. So I've listed them all. I put dot plot M. I'm going to turn that on, and we can see that dot plot come up. You can also do the zoom fit, the little plus sign here, and it'll give me a nice way to look at that. But there is my dot plot. And then we could just copy the dots down. I'm not as big of a fan of a dot plot than the other ones. I think I prefer stem and leaf and histograms, but it's nice to have options. So let's see. So the first one we have here is 45, and we want to, just kind of like when we were doing the stem and leaf, we want to align our dots. So anytime we have just a single dot, we want to make sure they're kind of in line horizontally. We had 2 of them here right below 70. In the 75 region, I had 1, 2, 3, 4, because we had a bunch of 74s. You can see I had a 74, a 74, and a 74. And am I missing? I'm missing a 74. Oh, and I have a 75. and I have a 76. And so it kind of gets, they don't have to be exactly in the right spot. You can, so like I wanted this to be 74s and 75s. So you don't have to have one column of dots for every single different number. You can group some together. I have a few of them here in the low 80s. You can see I have 80, 80, 80, 80. I have four 80s. Oh, and 78s. Actually, that was probably my 78 column. Sorry, I've got 78, 78, 78, 78. So I have four 78s. I have four 80s. So I'm going to put those there too. So you can kind of see how I'm doing this. I have two 81s. And I have an 82. I can split those up if I want, or I can just kind of group them all together, 81 to 82. I mean, you should probably have it, if you're going to do it by twos, make sure to have all of your columns by twos. But for time's sake, here we go. All right, and the last little bit. Don't forget to label your graph. Yes. Okay, choosing an appropriate display. As a general rule, histograms are the most appropriate for large data sets. Definitely easier to draw a nice bar for every interval than to try to put little dots or every single digit on a paper. And while stem and leaf graphs and dot plots are better suited for small or moderately sized data sets.